Can you hear me?
Yes.
Yes.
So again, can you hear me? I believe you can. So I visited all 3 breakout rooms and I noticed there was total silence and no response whatsoever. So I'm just wondering, is this material clear so far?
I had a question about how to use the initial values and the initial function.
Are there any questions?
Can you hear me, Professor?
You can hear me, right?
Yeah, I can hear you.
Yeah, we can hear you, but
One
so
student has a
yes.
question, but
Yeah,
I
what
don't
was
know
the
if you can hear
question?
him.
someone had a question about how would we use the initial values, like the y0 equals 1 and the y prime 0 equals 2? Like where would that go?
Yeah, so you will need to check that these 2 functions satisfy this differential equation and these 2 initial conditions. So you will need to substitute 0 into each function here and make sure you're getting true statements. Make sure these conditions are satisfied. Well, let's try the first one. I'm going to start with y sub 1, which is e to the t, and I'm going to find the first and second derivatives. This one is very nice because the derivatives are exactly the same as the function. We're very convenient. So I'm going to substitute second derivative and then first derivative minus 3y. Is this true or false? 1 plus 2 and then minus 3, 0, right? True. And similarly, we're going to make sure that y of 0 is equal to 1, right? True. And y prime of 0, I'm going to use this derivative now. Again, e to the 0, e to the 0, I'm getting 1, not negative 2. Let me check my the copy of the book here. So 22 showed that form a fundamental set of solutions. Oh, and then find a solution satisfying. Okay, so you know what? We're not supposed to check this here. I didn't read the question correctly. So we will have to first show that this function and this one satisfies the differential equation only. Okay, so we don't have to check this yet. So these 2 conditions will be used later when we combine the 2 fundamental solutions. Then we find constants C sub 1 and C sub 2 that satisfy these 2 conditions. So at this point, we just need to substitute. So this is the second function, e to the negative 3t. The derivative is negative 3e to the negative 3t. Am I correct? So the second derivative will be 9e to the negative 3t. And again, we just need to check that it satisfies the equation. The equation, y double prime plus 2 times y prime and minus 3 times function y sub 2 e to the negative 3t. So we have 9 e negative 3t minus 6 e negative 3t minus 3 times e negative 3t. Is it equal to 0? Yes, it's yeah, it's fine. So again, don't worry about this condition yet. Y of 0 equals to 1 and y prime of 0 equals -2. These will be used for when you find general solution. Once you have your general solution, you use these two conditions to find C sub 1 and C sub 2. Okay? Are there any questions so far? All right, so far, both functions satisfy the differential equation, but we need to make sure they are independent. So I'm going to take ratio y sub 1 divided by y sub 2, e to the t over e to the -3t. So this is the same as e to the t times e to the 3t. Not a constant, am I correct? Not a constant. Not a constant. So by the definition 1.22, that was a while ago. So by this definition, if ratio is not a constant, right? Functions are linearly independent. So y sub 1 and y sub 2 are linearly independent. Okay, so y sub 1 and y sub 2 are linearly independent. And we can also find Wronskian, right? We can do that to make sure. We already know the answer, but it's just to demonstrate the method. So we take determinant of the matrix. The row will be e to the t, e to the -3t. That's the first row. And the second row will be derivative, right, of the first. And then here we have derivative of the second solution. So let's multiply along the first diagonal and subtract from their product along the other diagonal. Do you agree with this? Can anybody confirm? Are you getting this?
Yeah, that's what I got.
Very good, excellent. So this is certainly not 0, right? So not 0, this exponential can never be 0. So yeah, we have confirmation that our two functions are linearly independent. They both satisfy the differential equation and they are linearly independent. Therefore, they form a fundamental set of solutions, for sure. And this is now where we say general solution y of t will be c sub 1 times e to the t plus c sub 2 times e to the -3t. So is the general solution. So if you have a fundamental set, you proved that they both satisfy the DE, and you also showed that they're linearly independent. So once you have that fundamental set, you have the general solution, which is a linear combination of those two functions, y sub 1 and y sub 2. So now we can use the initial conditions, right, to find c sub 1 and c sub 2. So y of 0, I'm going to plug in 0 for t. We get c sub 1 times e to the 0 plus c sub 2 e to the 0, which is c sub 1 plus c sub 2 has to be equal to 1. And for the second equation, I will have to first take derivative of this. So y prime of t c sub 1 e to the t, and then minus 3c sub 2 e to the negative 3t. So this is the derivative, right? And we're using this initial condition, y prime of 0 is equal c sub 1 minus 3c sub 2, and then equals negative 2. All right, we have two equations. System of two equations, and there are two variables. We should be able to solve it. So I'm going to start by, I'm going to isolate c sub 1 on one side, so 3c sub 2 minus 2, and I'm going to plug that into the first equation. So 3c sub 2 minus 2 plus c sub 2 equals 1. All right, so this is 4c sub 2 equals 3, from which we get c sub 2 equals 3/4, and c sub 1, 3 times 3/4 minus 2, 9/4 minus 8/4, looks like a quarter. So I believe that we have c sub 1 and c sub 2, so we're ready to write the particular solution. So number 13. So our particular solution will be y of t equals 1/4 e to the t plus 3/4 times e to the negative 3t. So this is the particular solution, our final answer. And the only thing that could be useful is checking, right? We can always check. How do we check that this is correct? Since this problem is an even problem, right? So this is number 22, I believe. Even problems do not have answers in the back of the book. Am I right? Yes, that was number 22. So it's a good idea to check by substituting this function into the differential equation and into the initial conditions. Do you agree?
Yes.
So are there any questions? All right.
I just have one more question before you check.
I'm going to write down your homework. So this will be section 4.1, complete at home. Complete at home. So again, there is always a way to check if this solution is correct, right? You would have to take derivative y prime, y double prime, plug everything into this equation and make sure you're getting 0, right? Y of 0 is equal to 1, that I can see right away, right? A quarter plus 3/4 will give us 1. And then derivative of y at 0 equals negative 2. You can always check. Do you agree?
Yes.
All right, thank you. I strongly recommend, to check, especially if it's a test or quiz, it's a good idea to check. So let me write down homework, section 4.1. So let's try 1 through 9 odds. 13, 15, 17, 19, and 23, 25. So try those problems at home and let me know. If you have any questions, we'll take a look, okay?
I have one more question about the last
Any
example.
questions?
There is a question. Can you hear us, Professor?
I'm sorry?
There is a question.
One more time?
We have a question.
I cannot hear. Is there a question?
Yes, there's a question.
It's all right.
Because I couldn't hear what you said. Do you have a question?
Wait, Professor, can you hear us?
Yes, I can hear you, yes, but I couldn't hear the question that you asked earlier.
Okay, so my question is about the general solution. How did you
Do you
get
have
the
a
form?
question?
There's a
No,
question
ma'am.
about the general solution.
I cannot hear anything right now, so I'm not sure. If you want, you can ask me through. Oh, I'm sorry, there's a chat here, and I just. Yeah, it's a good idea because so you can hear, that's great. But I couldn't hear the question you just asked me. So if you want, you can type it or maybe try again because I cannot hear anything right now. All right, yeah, that's great. Yeah, with the general solution, how did you get the format of the solution? Oh yes, so for this one, I used the theorem we wrote a little bit earlier. Let me find it. So we said right here, theorem 1.23. Let me move this a little bit out of the way right here. So theorem 1.23, we said that if you have two fundamental linearly independent solutions, y sub 2 and y sub 1, then linear combination will be the general solution of the differential equation. Okay, so this is why in the problem that we just completed, I combined, right? I combined, this is linear combination of our fundamental solutions. Do you agree? Can you hear me?
Yes.
Okay, perfect. Thank you so much. So any other questions, please let me know. And we should start checking chat because I actually completely forgot to check it. And yeah, so also, any other questions? All right, so in that case, so please make sure to do this homework, work on the quiz, right? We have quiz posted. Your quiz number 4 is getting ready as well. So I should be able to post quiz number 4 probably soon. We should be able to cover one more section, 4.2 before you can take your quiz number 4, okay? So again, any questions? All right, so in that case, I want to wish you a wonderful weekend, right? Wonderful weekend. And please stay safe and healthy, all right? And I'll see you next week.
Thank you. You too.
Thank you.
So
you too,
I'm going to end the meeting. Let's see.